welcome back, and I hope you're doing well. This is Jennifer Chemistry Official, where we make chemistry friendly for our students. Today we are dealing with valency, and in this lesson I want us to relate it with what we have been dealing with in our previous videos, and that is ionic formation, because during ion formation we have either the losing or the gaining of electrons, and that is what will help us in the determination of the valency. Actually, ion formation is one of the ways through which valencies are determined. So in this lesson, we will be looking at the meaning of the term valency, and then I will teach you on two major ways through which you are able to determine the valency of any given element or even a radical. We have that new term radical. I'll be telling you on what it is. So we begin. Valency is the combining power of an element. So you write, I hope you're writing. It is the combining power of an element. When you hear that it is a combining power, it is to mean that sometimes elements, or even we can call them atoms, they usually combine. And when they are combining, it means that is in the subtopic of structure and bonding. So they usually combine. So by them combining, you are able also to tell on what valency any given element or an atom has. So the other way of giving the meaning of valency, a valency can also be seen as the number of electrons that an atom either gains or loses. The number of electrons that an atom either gains or loses so as to attain a noble gas configuration. Or so as to become stable. So again, during ion formation, we were able to see some of the atoms gaining, some of the atoms losing, and all was to make them become stable. This that we are calling the noble gas configuration, it is a configuration of those elements that are in group 8. Last time I mentioned something that was very important, and if you are new, you can please go back and confirm what we were dealing with in our previous videos, because we are building on something, and you can only understand what we have today by having checked on what we had previously. So I mentioned something to do with the 3 rules that are usually followed when you are writing when you are filling energy levels for the first 20 elements in the periodic table. And one of the rules was that the first energy level for the first 20 elements should have a maximum number of electrons, that is 2 electrons in the outermost energy level. And that when any given atom has a maximum number of 2 in the first energy level, and let's say like helium, that is the only energy level that it has, then we say that that element is stable. So helium is usually not in group 2 but rather in group 8. Though it has 2 electrons in the outermost energy level, it cannot be in group 2. It is placed in group 8. Reason, the first energy level that it already has is already full with a maximum number of 2 electrons. The other rule was that the second energy level for the first 20 elements should have a maximum of 8, and the noble gas that usually has that rule fulfilled is neon, which has 2.8. so both of its energy levels are already full, and now that the second is already full with 8, we place it also in group 8. So the other one was argon, still under the first 20 elements in the periodic table with an electronic arrangement of 2.8.8. So again, the third rule being that the third energy level for the first 20 elements should have a maximum number of electrons, that is 8. So again, it is stable. So when electrons are usually lost or gained, that is to make an element become stable. So I'll be showing you on two major ways through which you are able to determine the valency of either elements or even radicals. So one of the ways, so write a subtopic, two ways used to determine valency. Two ways used to determine valency. So remember, I'm trying to simplify and help you chew the knowledge in chemistry in a way that you'll be in a position to do calculations and even other stuff in chemistry. So one of the ways is by checking on the charge. Checking on the charge on the ions or radicals. Checking on the charge on the ions or the charge on the radicals. Radicals in this case is a group of atoms that react as a unit, and they usually have a net charge on top there. I'll be giving you a few examples. So this is one of the ways, and from our previous video we will use some of the ions that we already did. So one of them was magnesium ion. That is one of the ions that we dealt with in our previous video. Capital M, small g, 2 positive, that is magnesium ion. By just looking at the formula of that ion, we are able to notice that we have a 2 here. So the valency will be 2. But we will not indicate the charge, because when you are dealing with the valencies, they are usually whole numbers with no charge. They are chargeless. So note that it is very, very important. No charge is usually required when you're writing the valency. Remember, for magnesium, we said that it acquired this charge now that it had lost 2 electrons. It had lost 2 electrons, and so it was left with 2 extra positive charges, and we combined them to have 2 positive. So the valency is 2. Still, from our previous videos, we had sodium. Before, we had sodium as Na positive. It was supposed to be Na1 positive. This was actually what was seen from what we did. But we ignored this one. Now that whether the one is there or it is not there, it is still be the same. Look at this. This is 1 positive. What is this? Even without writing the 1, it is how many positives? Only 1. So we usually do not repeat, because this is a kind of a repetition. So we avoid the writing of the 1, but actually there is supposed to be this 1. Just like when you are dealing with magnesium, we had written as Mg 2 positives, like that, but we ended up summarizing it as 2 positive. So the same with this one. So for sodium, let's go back to sodium. I hope you have understood how I have done it, sorry. So the valence here is 1. So Mg2 positive, which is magnesium, it is standing in for group 2 elements, or the alkaline earth metals. So any element that is in group 2 will always have a valency of 2. Let me give examples of those elements in group 2 from the first 20 elements. The first one is beryllium. Then down there we have magnesium. Down there we have calcium. And then going on and on down the group. Always, for those ones, they always have a valency of 2. Sodium is here to stand for, or to stand in for, the group 1 elements. Those are the alkali metals. The alkali metals. Those are the group 1 metals. So sodium is there to stand in for the group 1 elements or the alkali metals, and for them it will always be valence 1 throughout down the group. So again, for group 1 metals, we begin with lithium, then followed with sodium, followed by potassium for the first 20 elements, then downwards. And something should be noted. When I was teaching you on how to write, or rather to draw a periodic table, up there in group 1 we had hydrogen. But when I was mentioning about the examples of group 1 elements, I have not mentioned hydrogen anywhere. Reason is, hydrogen is usually not considered as a group 1 element. When we are mentioning the group 1 elements, we begin from lithium, then sodium, then potassium, downwards. Why is hydrogen not considered a group 1 element? It is because for hydrogen, it can either gain or lose. And it can gain like a halogen or lose like a group 1 element. Actually, if you check on the past papers, you will not miss that question. Why hydrogen is not considered a group 1 element? Reason is, hydrogen can either lose the only one electron that it has, and by losing it, it will be left with only one proton in the nucleus. Check on this. Hydrogen has only one electron. It has one proton. It has 0 neutrons. This electron is in the energy level, the only one energy level that hydrogen has. This one proton is in the nucleus. The same with the neutrons, though it does not have any neutrons, but neutrons are usually also in the nucleus. So when hydrogen loses this one electron that it had in the only one energy level that it has, for hydrogen, it only has one energy level, which is considered as both the innermost and also the outermost, the only one that it has. So if it loses this one electron, it will end up losing the only one energy level that it had, so it will only be left with the nucleus. And in the nucleus, we only have one proton. And the protons are usually shown with a positive charge. So it does not have electrons anymore because it has already lost it, like the group 1 elements. And so it will be left with only one proton. And that is why in acids, hydrogen is referred to as a proton with this symbol of capital H and a plus on top. So hydrogen can either gain or lose electron, the only one electron that it has. When it gains, it behaves like a halogen. Halogens are group 7 elements. Group 7 elements like chlorine, they can only gain one electron so as to become stable. So you see also for hydrogen, it can only gain one. It cannot gain more than one. Why? Because it has only one energy level, and the first energy level can only have a maximum of 2. So hydrogen can gain like the halogen, so it will gain 1, and when it gains 1, it will now be behaving like a group 7 elements. If it loses the only one electron that it had, it will behave like the alkali metals, the group 1 metals, and that time it will be referred to as a proton. Let me also mention something still on hydrogen. When hydrogen behaves like group 1 elements, and that is the time when it will be referred to as a hydrogen proton, when you are writing formulas of different compounds using it as a hydrogen proton, it will always be written on the left hand side of the formula. For example, when you are writing formulas of different acids, the common acids like the nitric 5 acid, the sulfuric 6 acid, the hydrochloric acid, you see hydrogen is on the left hand side. That is when hydrogen is behaving like a group 1 element. In the formulas, it will only be written on the left hand side. If it behaves like a halogen, and like a halogen, it will be behaving by gaining 1 electron. That time, it will no longer be written on the left hand side. It will then be written on the right hand side in what we call the hydrides, the metal hydrides. For example, in the formula like this one, sodium hydride, you see hydrogen is written on the right hand side. So when it behaves like a group 1, in the formulas of different compounds, it will be written on the left hand side. If it behaves like a halogen, it will now be considered like a nonmetal, and it will be written on the right hand side of the formula. So we are continuing with the valences. I'll be showing you more as we continue. Make sure that you're also writing good notes.